Okay, good day, grade 8 students. Okay, for today, what we're going to discuss is the introduction for triangles. So we're going to see a lot of theorems, postulates, definitions about triangles. So we're not going to dive deeper into those topics. What we're going to do here is we're just going to give you a brief introduction on how to solve for angle measurements of a given triangle. Okay, so solving for the measurements of the angles and also the sides. And of course, at first, for the introduction, we're going to find the given applications, the applications of triangles, and also the different types and classification of triangles. So triangles can be seen everywhere. Okay, so in nature, you can see triangles, but mostly you can see them on man-made objects. So as for this one, we have there a roof. So a roof or a building here that's shaped like a triangle with trees in the middle, with tree branches in the middle. So that's kind of like a modern architecture style of creating a house shaped like a roof or a gabled roof. Okay, and we also have here a building. So this is also a design, a proposed design for an architectural building that uses different types of triangles in order for it to look, what do you call this, look more economic or more modular. Okay, so this building is just an architectural plan, but if it's proposed or if it's implemented, this will look like a very beautiful building that uses the concepts of triangles in all of its dimensions or all of its parts. Then we also have here in New York, we have the Flatiron Building. Okay, so the Flatiron Building, so you might have seen it on movies. If there are movies around New York, so this is one of the most prominent features aside from the Statue of Liberty. You have the Flatiron Building, so it's shaped like a triangle, figure. Okay, so I think it's located in Broadway and Broadway Avenue. Okay, so this is one of the most prominent features in New York. So that's one of the applications of triangle by man-made structures. And also what we've seen on the polygons video, here you can also see the triangles. A lot of triangles are actually used on the Louvre. So the Louvre can be found in France, in Paris. So it's a shape like a tetrahedron, and if you look closely at the glasses, if you zoom at the glasses, you can see many more triangles there. Okay, maybe isosceles triangles, scalene triangles. We're going to define those terms later. So there are a lot of applications of triangles, and also in nature. So you can find in nature the shape of triangles, so such as this flower. Okay, so this flower has two triangles in it. Okay, so very beautiful flower. And also, if you notice, geese. So geese, when they fly, they always fly on a flock. And when they are on a flock, they form a V pattern. Okay, so even though the V doesn't necessarily look, it's not like a triangle per se, so it's just a V. Okay, but if you kind of imagine it, it's kind of like a triangle, right? So why do the geese form, why do those flock of geese, why do they form that pattern? Okay, so the leader there, usually the leader is the one at the center, and the geese that are not like feeling well or are sick or are disabled or have some physical incapacity with them, they fly at the back. Okay, quite at the back. But there are geese that support them. For example, an incapacitated geese starts to fall at the back. There's going to be one geese at the front who's going to save them, and then they form another V-shaped pattern. And so it continues. So and it's also for navigational purposes. So that's why they have that kind of pattern when flying or searching for a place to nest into. Okay, also we have here a shamrock leaf. Okay, so a shamrock leaf or a clover leaf forms a triangular pattern as well, and triangles can also be found on ferns. Okay, so there's a lot of applications for that, so for triangles. So as you can see, the triangular pattern of ferns So from big leaves that start at the bottom, they get smaller and smaller and smaller until they form a triangle shape pattern for ferns. Okay, so formally defined, we know that a triangle is a three-sided polygon, has three vertices, and has three sides. So we can call this triangle as triangle TRI, or triangle IRT, or triangle ITR, whatever you may choose. And it also has three vertices, point T, point R, and point I. It also has three sides, side TR, side RI, and side IT. Okay, so that's how we do it for triangles. That's how we name them. And then we have three triangles based on the measurements of their sides. So the first one is the equilateral triangles. The most common one is a regular polygon. The equilateral triangle has all sides that are congruent. So that means all of their sides are the same. Then we have an isosceles triangle. An isosceles triangle has two sides that are congruent. So they have two legs or two sides that are congruent. And then we have a scalene triangle. So a scalene triangle is a triangle that has no sides that are congruent. And if you want to base them on their angles, we have four types of triangles. So for the first one, we have the equiangular triangle. So if it's a triangle, so that's kind of like 180 degrees, right? So each interior angle of the equiangular triangle measures 60 degrees because 60 times 3 is 180 degrees. So that's for the equiangular triangle. All of their angles are 60 degrees, or all of their angles are the same. Then we have the acute triangle. So an acute triangle has all angles that are acute. So we can say that an equiangular triangle is also an acute triangle because all of the angles are 60 degrees and 60 degrees is an acute angle. Therefore, an equiangular triangle is also an acute triangle. Then we have a right triangle. So a right triangle is any triangle that has one right angle. And again, right angles measure 90 degrees. And also we have an obtuse angle. An obtuse angle is any triangle that has one obtuse angle. Okay. So for any triangle, there can only be one right angle, or there can only be one obtuse angle. Okay. Okay, so we have a problem here regarding a triangle. So we have here a triangle MSF. Okay, so triangle MSF is an isosceles triangle, which means it has two congruent sides. We want to find the measurement of side FM, side SF, and side MS, and angle beta, and angle gamma, given that side FM is 2x minus 8 degrees, and the measurement of angle MS is twice the sum of its adjacent sides, and the perimeter of the triangle MSF is 92 degrees. So let's try to first solve for the perimeters because that's the difficult part. The angles here are quite easy to solve. Okay, so we can try the perimeter first. Okay, so to get that off the bat. Okay, so we have here the perimeter is equal to 92 degrees. Okay, so to get the perimeter of a triangle, we simply have to add the measurement of all of its sides. So that's side SF, that's side FM, and side MS. So we all know that this is an isosceles triangle, so that means the measurement of side FM is the same as side SF. So that means side SF also measures 2x minus 8 degrees. Quantity 2x minus 8 degrees. So therefore, we can add the three together, but we're still missing the measurement of side MS. But it says here that the measurement of side MS is thrice the sum of its adjacent sides. So how do we get the sum of its adjacent sides? So since we know that side SF measures 2x minus 8 degrees and side FM also measures 2x minus 8 degrees, then we can simply add these two angles. So that's going to be 4x minus 16. And then, of course, it's written here thrice the sum of its adjacent angles. So that means we have to multiply 4x minus 16 by 3. There you go. So that's the measurement of side MS. Side MS measures 3 times 4x minus 16. So that's 3 times 4x minus 16. And the perimeter here, the perimeter for the triangle is 92 units. So there, we can now solve for the measurement of the sides by first solving for the value of x. Okay, now that we have the perimeter, the value of the perimeter, and also the value of all of the sides, we can get the value of x and solve for the value of the sides, the exact value of the sides. Okay, so how do we do that? We have to equate the given values that we have here, the given expressions that we have for the different sides. So we have here 2x minus 8 for side SF, and then you have to add that to 2x minus 8 for side FM, and then you have to add 3 times 4x minus 16, okay, is equal to 92 units. Okay, so this is the perimeter of the triangle. We added the three sides, and it has to be equal to the 92 units that's given on the problem. So we have here 2x, okay, so 2x plus 2x, and then 3 times 4, so that's going to be plus 12x, okay, so that's going to be equal to 92, and then you have here a minus 8, and if you transfer that to the other side, that's going to be plus 8, and then this one also transfer to the other side, that's going to be plus 8, and then you have there a negative 16, but you have to multiply it first by 3. Okay, so what's 16 times 3? So you get there 48. So that's going to be negative 48. Okay, 3 times negative 16, so that's negative 48. And if you transfer that to the other side, that's going to be plus 48. So we have here 2x plus 2x, that's 4x, plus 12x, so that's going to be 16x is equal to 92 plus 8 plus 8 plus 48. So the answer is 156. Okay, and if you divide that, okay, so the answer here is 156, and if you divide 156 by 16, okay, so you get the value of 39 over 4. Okay, so the value of x is 39 over 4, or simply 9.75. Okay, so now that we found the measurement for the value of x, okay, so the value of x is 39 over 4, or simply 9.75, we can substitute this value to the side measurements that we have here. So we have here side FM, side SF, and side MS. So we're going to substitute 2 times 9.75, since that's the exact value, minus 8. So 2 times 9.75 is simply 39 over 2, then minus 8, so that's going to be 23 over 2, or 11 over 5. So side FM and side SF measure 11.5 units. Okay, so I'm sorry, I clicked another wrong. Okay, there you go. So 11.5 units. Okay, 11.5 units. There you go. 11.5 units. Then we have 3 times 4x minus 16. So the next step that we have to do is we have to substitute the value of x for 3 times 4x minus 16. So what we have here is 3 times 4 times 9.75, close quantity, minus 16. So what we have here is 4 times 9.75, so that's 39, minus 16, so that's 23, and then times 3, so you get 69. Okay, so you get 69 units. But the measurement of, or the perimeter has to be, 92 units. Okay, so what we're going to do here is we have to multiply 11.5 by 2, because this is just the measurement of one side. This is just side FM. So to get the side FF, since they're congruent, we just multiply that by 2. So that will give you around 23 units. Okay, so 69. So we have here 69 units for side SM, 69 units plus 23 units. Okay, so what's 69 plus 23? So that's simply 92 units. And therefore, we solve the value for side FM. So it's 11.5 units. For side SF, it's 11.5 units. And for side MS, it has 69 units. Okay, so solving for the measurement of the angles. So this triangle is an isosceles triangle. So if it's an isosceles triangle, that means, so I'm going to use a black ink so that we can see it much clearer here on our illustration. So we have here two congruent sides. So these two congruent sides also have the same angles. So if this is 47 degrees, so this is also 47 degrees. So we can solve the value for beta right away, because we all know that the measurement of a triangle is 180 degrees. So let's switch back to white. Okay, so to get the measurement of angle beta is equal to, since we don't know the measurement of angle beta, we have their beta plus 47 plus 47 degrees, and the measurement of, I'm sorry, so this is not the measurement of angle beta, this is the measurement of triangle MFS. Okay, so the measurement of triangle FMS is 180 degrees, so that's going to be beta plus 47 plus 47. So what's 47 plus 47? That's simply 94. And to get the measurement of angle beta, we have to subtract 180. We have to subtract 94 from 180. So 180 minus 94, and you get the measurement of angle beta, okay, is actually 86 degrees. Okay, and if you check that, okay, so we have here 86 degrees for angle beta, and then we have here from angle gamma. Angle gamma measures 47 degrees, and angle S measures 47 degrees. So if we add those three, 86 plus 47 plus 47, you get 180 degrees, the measurement of a triangle. So therefore, we can conclude that the measurement of angle beta is 86 degrees, and since the measure of angle S is the same as angle gamma, the measurement of angle gamma is 47 degrees.